this week will be taught very similarly to last week, where I'll have slides, and I'm going to accompany the slides with some live coding as well. So, starting with the first topic, we have data structures. Data structures are essentially just an organized way of storing data. So, whether it's ordered or whether it's accessed in a certain way. And the first data structure we're going to look at is lists. So a list is essentially just a sequence of data. So as you can see, you have two rows. The top row represents the location of the item in the list, and the bottom row represents the actual data. So you can imagine this list storing a list of test scores, for example, where the first test score is 77, and that's at position 0. Because lists in Python and many other programming languages are 0 indexed, meaning that the first element is actually at index 0 rather than index 1. The second element is at index 1. So we're going to switch over to some code. So far, the only way we've stored data is within basically individual variables, like integers. But you can imagine if you want to store a lot of data, it gets very tiresome to define new variables that just store a single piece of data. Like, let's say we want to store these scores, 7 different scores, and we've had to do it by defining 7 different variables. But if we use a list, we will have just a single variable called scores, a list, and we assign that to the actual contents. So we start off by using square brackets to declare the start of the list. And then each piece of data will be separated by a comma. So we have 77, 62, 68, 42, 59, 61, and 55. Now, all of this data, rather than assigning it to individual variables, we have just under a single list by the name of scores. So if we print scores, we'll see that it prints out the contents of the list. So that's nice, but obviously we're going to want to access individual variables or individual pieces of data rather, instead of just doing the whole list. So if we want to get the first item, remember that lists are 0 indexed, so we're going to access it using index 0. We simply write the name of the list, then we use square brackets to start declaring the index, and then we put in the index. So if we want the first item in the list, we do scores, square bracket 0, and then that will get us 77. And remember, because they're 0 indexed, even though there's 7 items in the list, the last item will actually be stored at index 6 rather than index 7. If we try and access index 7, we'll get an error. So the last item, 55, is at index 6. But if we try to do scores index 7, we're going to get an error because that's actually beyond the range of the list. So you can see how it's a lot more concise storing a sequence of data in the list rather than defining individual variables and assigning the data to the variables. And so here we see the index starts at 0 and it goes to 6. But we can actually use a negative index to start at the other end of the list. So if we want the last item, we can use -1. And it will go to -7 because the 0 represents the first item, whereas -1 represents the last item, and it goes in the reverse order all the way to -7, which will represent the first item. So lists can actually store data of different types. So even though the previous list has just integers, you can mix and match different types within the same list. So as you can see here, the first item we're storing is a string, the text cat. The second item is an integer. The third item is a float. The fourth item is a Boolean, true. The fifth item is also an integer, and then the sixth item is another string. And that's perfectly valid in Python. You don't have to have data of all the same type. You can mix and match the different data types, even with the same list. So just to give an example that proves that it's actually possible, we can define a list called strange list equals a list with the contents of true, 0, and then let's have a string saying hello. And if we print the strange list, you'll see that the code compiles perfectly fine, and it will print out. Well, it doesn't because of this. But if I remove the error, it will compile, and it will print out the list with the Boolean, the integer, and the string hello. So you can mix and match different types even within the same list. And Python provides a couple of functions that you can actually call on lists. So when you define a list with a certain number of items, you can actually expand that list because the lists are dynamic in Python by doing append, or you can shrink it down by doing remove. So append will take the item that you pass as a parameter, and it will add it to the end of the list. Remove, it does something different. Remove searches for the first instance of the item and then removes it. Pop removes the item at a specified index, and then sort actually sorts the list in ascending order. So just to showcase these functions, we have a list called scores. We'll print. Let me just get rid of the code and actually showcase. So we have scores. Initially, you can see we've got 77, 62, 63, 62, and 59. And if we do scores.append, let's add another score of 90. You see, if I print the list again, that it would have actually appended a new piece of data, so the integer 90, to the end of the list, and the list has actually expanded to accommodate that. If I call remove, remember that it only deletes the first instance of the data that you pass to the function. So if I do scores.remove 62, notice that there is 2 integers with the value 62. And because remove only removes the first instance, it will just remove the second item. So if you can see, if I print the list again, print scores, you can see it deleted only the first instance of 62. So you have 77, 62, 63, 62, 59. And then the third line, once we've called remove 62, it didn't remove both the instances, only the first instance that it found. So keep that in mind. When you're calling remove, it won't remove all of the instances of that item, only the first one, in the order that it finds it. And then, of course, we can also call sort, which doesn't take, it actually has an optional parameter. You can provide true if you want to reverse sort. So if you want it in descending order, you'll pass true. But if you don't pass anything, it'll be in ascending order. So it will sort the list, and then if we print it out, we'll see that the scores are now in ascending order. So it starts from 59 and goes to 90, and they're all ordered. One thing you should keep in mind, if you have a list of different types, so let's say that scores had a string, hello. This will actually not run. It will result in error because we're trying to sort a list that has types that cannot be compared. So you cannot compare a string to a number, which is why if I run this now, it will result in an error because it's trying to compare one of the integers to the string. So if you're trying to sort a list, make sure that you have types that are actually compatible. So you could have a float, that's fine, because you can compare an integer to a float. They're both numerical. This will compile and it will run. But you cannot have something that cannot be compared to a value. So you cannot have, for example, false, because this also cannot be compared to an integer because it's not numerical. Okay. So we've got lists, and then we move on to multidimensional lists. So since lists can contain any data type, naturally you can also have a list within a list. So here, we've got the indexes in blue and the data in green. So at index 0, we have another list, which contains the elements 1, 2, 3. At index 1, we have another list, which contains 4, 5, 6. And you can kind of imagine this as a cube, or rather a square, a 2D list, where the x is the first index, and the y is the second index. So if I wanted to access the number 3, I would get the first index, which is 0, and the second index, which is 2. It'll make more sense if I actually showcase how this works. Okay, so let's say this list represents the scores of 3 different classrooms. So we have classroom 1, which got 75, 62, and 67. Classroom 2, which got 61, 59, and 54. And classroom 3, which got 61, 50, and 52. And you can see the way I define this list is the same kind of syntax, but where you would put the integer or the Boolean, you simply put another list. And then the syntax for accessing the individual elements of the multidimensional list is very similar. So if I just want to access the first element, I'll do print class score 0. And this will return the first element, which is another list. So if I want to access an individual score, I'll have to provide another index, which will contribute to the index of the second list. So if I want to access the second score of the first list, I'll do class score 0 and then 1. And if I run this, I'll get 62. So you can see how the first index I provide contributes to getting the list, and the second index will correspond to getting the item within that list. So if I want to get something from the second list, I'll do class scores 1. And let's say I want to get the third item, I'll provide the index 2. And this will get me 54. And you can actually go further. So you can have lists within lists within lists, but you rarely need anything more than 3 dimensions, because it's just very rare to come across things that require this kind of structure where you've got a list within a list within a list within a list. So the most common will be a single dimensional list, which we've seen before, but 2D lists and 3D lists also do come up, so just so you're familiar with how they work. Okay. So instead of selecting individual elements, you can actually select sections of a list. The syntax is very similar, so you have the square brackets, you provide the start index, the end index, and then you have an optional third parameter, which is a step. If you provide a step, it will take every nth item. So if I provided a step of 2, then it will take an item, skip an item, take an item, skip an item. So let's work on the scores list. Get rid of this old code. If I want to take, for example, the first 3 scores, I'll do print scores, the square brackets. The first index will be 0, and then I'll go to 3. So keep in mind that the first index that you provide is inclusive, but the second index is exclusive, which means that it will get the items at index 0, index 1, and index 2, and it won't get 3 because it's exclusive. So even though we've set 0 to 3, it actually only gets the items at index 0, 1, and 2. As you can see, 77, 62, and 68. Let's say we want to take all of the items, we'll go from 0 to 7, and that will just return all of the items in the list. And if you provide a step, then it will take every nth item based on that step. So if I have 2, it will take an item, skip an item, take an item. So as you can see, it took 77, it skipped 62, it took 68, skipped 42, took 59, skipped 61, and took 55. And this doesn't have to be, so you can change this to anything, it could be arbitrary, so you can have every third item, in which case it will take 77, skip 62, skip 68, take 42, skip 59, skip 61, and take 55. So that's how you can basically slice a list and take individual sections of that list rather than the entire list. And you can also omit these steps. So you could have, let's say, every element from the beginning. So you just provide a start index. Let's not do begin, let's do from the third element. So you provide a start index, colon, and then you skip the end index. Scores. So you can see it started sampling items from the third item because we provided an index of 2. And we skipped the end index, so it just carried on until the end of the list. Okay. So we said we're going to go over data structures. We've covered lists, and we have 2 more. We have tuples and dictionaries. So tuples, very similar to lists. The way you define them, as you can see, is also very similar. The only difference is that instead of using the square brackets, you use the regular rounded brackets. So you can see, you can define it in the very similar way to a list. The only difference is that a tuple is immutable. So once you declare and initialize a tuple, you cannot reassign it to different items. So let's give an example. Tuples. So you can see we have a list called scores and a tuple called scores tuple. Initialized in a very similar manner, but there is one crucial difference. Let's say I want to reassign an item from scores. So let's say I want to change the first item from scores to 90. And I'll print scores. That's perfectly valid because lists are mutable, so you can change the actual items within the list. And you can see when I print it, the first item has changed from 77 to 90. But if I try to do the same with the tuple, it will actually give me an error because tuples are immutable, so once you initialize them, there's no way of changing the data that's inside them. So if I do scores tuple 0 is equal to 5, it will give me a type error. Tuple object does not support item assignment. So keep in mind, whenever you see a tuple, you can access data within it. So I could do something like print scores tuple 0. That's perfectly fine. It will output the first element, which is 77. But you cannot reassign it to anything else. So if you see a tuple being initialized, you can be sure that the data that was originally in the tuple is exactly the same everywhere else in the code. Okay. And then final data structure that we're going to cover is dictionaries. So with lists and tuples, the way you were accessing values was using an index. And that was basically declared for you. So you can assume that in a list and in a tuple, the first item will always have an index of 0, the second will always have an index of 1, and so on and so forth. But you can actually declare these indices yourself by using a dictionary. So you can see a syntax here. With a list, you use square brackets. With a tuple, you use rounded brackets. And with a dictionary, you use curly brackets. The syntax is key, :value, which will basically declare the key that you want to associate with value. And that's how you're going to access that value. And then you define these pairs, as many as you need, and separate them with commas. So to give an example, dictionary. You can see here, we've got a dictionary called scores again. But now, rather than using a numerical index, where we just use 0, 1, 2 to access the elements, we use strings to associate these keys with the scores of the people that achieve the scores. And the syntax to access them is the same as with a list. So we have scores, but rather than doing scores 0 to get the first item, we're going to use the actual key that we've defined. So if we want to get the value that's associated with the key James, we do score, square brackets, James. And this will retrieve 67, because that's the value that's associated with the key. So you can kind of think of a dictionary as a list, but rather than using a numerical index, you actually define the keys that are associated with each value. And these could be any data type that's immutable, so you could have another dictionary which is, say, scores 2. And rather than using a string, you can still use an integer. So let's say we use 10. We associate the key 10 with the value 67, 11 with 54, and 12 with 62. So now we added 3 entries into the dictionary. The first one having a key of 10 and a value of 67, second one having a key of 11 and a value of 54, and the third one having a key of 12 and a value of 62. Now if we print scores 10, that will take the key that we pass in between the square brackets, and it will print out, or rather retrieve, the associated value. Okay. Let's do strings rather than values, integers. So the values can remain as integers, but the keys must be something that's immutable. So if we do scores 10, that'll be fine. It'll retrieve 67. Sorry, scores 2. It's a different dictionary. We're not using scores anymore. It's scores 2. There we go, 67. So it gave me an error there because I was trying to access scores, which uses strings as the keys, and I was trying to use an integer. But to demonstrate the different types for keys, you can have another dictionary called scores3, which is equal to, let's use a Boolean for the key this time, so you can have true, and let's associate that with 67, and let's have false, and associate it with 54. So if we now do print scores3, and then we pass the key as true, it's going to search the dictionary and get the associated value, which will be 67. And if I pass in false, it will search the dictionary, get the associated value of the key of false, and retrieve 54. So you can see the similarity between lists and dictionaries is essentially a list, but you define the index, you define the keys that are associated with each of the values. Okay, so that was all for data structures. Now we're going to move on to string slicing. This is very similar to list slicing in the sense that you want to retrieve a certain part of a string, and you do that by providing an index of the section that you want to retrieve. So you can think of a string as essentially a list of characters, and if you want to access a specific section of those characters, you provide the index associated with that section. So if we go into string slicing, we have a string. The variable is called fruit, and the associated value is apple. If we want to retrieve the first letter or the first character of the string, we pass an index of 0. So you can basically treat it almost like a list. And you see that retrieves and prints out the letter or the character A. And you can use the same technique as you used with lists, where you retrieve a certain section. So you can go from 0 to 2, and that will get the first 2 characters, remember, because the second index that you pass is exclusive. So get the character index 0 and the character at index 1. So we get AP. And all the rules are basically the same. The only thing that you cannot do is something like this. So you get an error because strings are immutable. So with a list, you could reassign basically an item at a specific index to a different piece of data. But with a string, because they're immutable, you cannot do that. So once you define a string, it has to basically remain as it is. You cannot do reassignment. Yeah, so you can see the syntax here. You pass the index within the square brackets, and if you want a specific section, you pass the start index, the end index, and optionally a step, which will again take the nth item within that string. Okay, and finally moving on to loops. So you often find yourself wanting to repeat a section of code multiple times. And obviously, one way of doing that is simply copying it and pasting it multiple times, but that doesn't scale, right? You might want to repeat a section of code 100 times or even more, and copying and pasting it that many times is just not very convenient. So you can use loops. There are two types of loops within Python. There is a for loop, which is used to repeat code a certain number of times, and you use this type of loop when you know how many times you want to repeat the code. And there is also a while loop, which is used to repeat a section of code while an expression is true. So you basically want to repeat the code until the expression evaluates to false. And you use this when the number of iterations or number of times you want to repeat the code is unknown. So we'll demonstrate for loops by iterating through a data structure, the list. So let's say you have scores. And you want to maybe calculate the average of all these scores. So let's set the sum equal to 0. You could do that by basically accessing each individual element and adding it to sum. So you could do something like sum plus equals scores 0, sum plus equals scores 1, and so on and so forth. And you'd have to do this for every element. So obviously it's not very convenient. Imagine the scores list would have 100 different scores, and you'd have to type this out individually, one by one. Instead, you can iterate through the entire structure by using a for loop. So you do for, and then you put a name for each item. So let's say score. This doesn't have to be named score. It could be anything. It could be X, it could be A. Just any name for the variable that represents a single item in the list or in the structure. In scores. And then colon, and then make sure you indent. So if I do this for score in scores, print score, you'll see that it iterates through the entire structure, and it prints out individual scores. So if I want to calculate the average, I will do sum plus equals score. And once I've exited the loop, once all of the scores have been added up, I can do something like print sum divided by 5, which will give me the average score because there's 5 items in the list, 5 different scores. So you can see the average is 69.6. Basically what this did was it went through the loop, so it went through the list. First it did 77, it printed 77, then it added 77 to the sum. Then the next iteration, it took 62, it printed 62, added it to the sum, and so on and so forth until it reaches the end of the list. And you can kind of simulate this behavior by calling the range function. If you want to execute a piece of code a certain number of times, let's say 5 times, you can do for x in range, and this is a function with 2 parameters. It will take a start and an end. And it will generate basically a structure with 10 different elements from 0 to 9, because the second parameter is exclusive again. You can see if I execute this code, it will print from 0 to 9. So if you want to iterate through a structure, you can use a for loop. You just declare the parameter that you want to represent a single item within the structure. So we did for score in scores, and the second time we used just x in a range. This is just an arbitrary name. This could be anything. It's not a specific keyword, so I could do a, I could do num, and it's just as valid. And then you write in, and the structure that you want to iterate through. So in the first case, we use a list. We can also use a tuple. That also is a valid structure to iterate through. So if I do scores tup, 77, 62, 55, 72, 82, I can do for score in scores tup, colon, print score, and it'll work just as well. You can see it iterated through the tuple. So that's for loops. That's used for iterating over a structure. It's used for iterating and executing code a certain number of times. And then we move on to while loops. These types of loops are used for executing code until an expression evaluates to false, or while an expression is still true. So this is used when you don't know how many times you want to execute the code. You just know when you want to stop executing the code, when the expression evaluates to false. So we have an example here. We have a function called sample temperature, and this will basically get the temperature. We've defined it as 60, and take away an integer, a random integer between 0 and 5. And then we have the while loop here, very similar syntax to the for loop, where you have the colon and the indentation. Inside, you just put the expression that you want to evaluate each iteration. And while it's still true, the body of the loop, which is these two statements here, are going to execute. So if we run this, basically you can imagine the system represents some type of temperature control, where you want to spin the fan while the temperature is above a certain amount. And each time the fan that is spinning, the temperature decreases per iteration. So you can see this time you had 60, 63. So you can see this time the loop executed 7 times. But because we're taking away a random value, the next time I execute the code, it might execute more times or less times. So you can see this time it executed slightly more times. So even though we use the same loop, the same code, the number of iterations changed in between executions because we're not executing the code a specific number of times. We're just executing it while the condition is true. And that's when you'd use a while loop. Also, it's important to note, you can actually use a while loop to represent any for loop, basically. So if we have, let's say x is 0, let's do a for loop for x in range 0 to 10. So we want to execute the code 10 times. This will just iterate through the structure, get x, and print it. We could represent this with a while loop by just setting a variable x equal to 0, and then while x is less than 10, colon, print x, and then each time we can increment x by 1. So with the for loop, you're iterating over a structure, and you stop execution when you reach the end. And with a while loop, you execute while the condition is true. So you can basically just set the condition of the while loop to be, we're not at the end of the structure, which will make the while loop basically behave as a for loop. So to give another example, let's say we have, again, the scores list. We can iterate through it by doing for score in scores, print score. But we can also iterate through it by defining an index variable, x again, setting it to 0, doing while x is less than 5. We can do print scores and use the index to access that element. And then also increment by 1. So you can see we can use a for loop to, or rather we can use a while loop to represent a for loop, but it just adds some extra steps. So we iterated over the scores with the for loop. We got 66, 72, 66, 92, 21. And then we used the while loop and iterated it over again, just using an index. We got 66, 72, 66, 92, and 21. There's also two loop keywords that you should be aware of. There is continue and break. So these are used within the loop body to basically control how the loop executes. We have continue, which skips the current iteration and then moves on to the next. And we have break, which completely exits the loop no matter what. So let's say we had a while loop with the condition being true. If we put a break within the loop, no matter what the expression evaluates to, it will just exit the loop and finish execution. So we have loop keywords. We've got a for loop, for I in range 0 to 10, so a for loop that executes 10 times. Then we have a print statement, this will be printed. Then we have continue, and then another print saying this will never be printed. So the first statement obviously executes, but then we have continue. So continue will halt execution of the current iteration and just move on to the next, which is why the second statement never gets executed. So as you can see, this will be printed 10 times, but because we used the continue keyword, it just skipped over the second print and moved on to the next iteration. But if we use break, it will exit the loop entirely and basically halts execution, so we're only going to get the statement being printed a single time. So you can see this will be printed, is executed, the print statement, and then it encounters break, and it completely exits the loop, even though it should still execute 10 times if we omitted the break statement. And this also applies to a while loop. So let's say we use a variable to control the while loop, while x is less than 10. We'll do print x, and then we'll do break. And this will only execute once because it's going to encounter the break statement and exit the loop. So you'll only get the value 0 being printed, as you can see here. And these are often paired with if statements. So let's say we have a list of items, and we're looking for a specific one. So let's say we have scores again, 66, 72, 54, 67, 81. And then we're going to iterate through the scores list using a for loop. And let's say we're looking for the score 54. We're going to do if score equals to 54, break. And it'll also print the current score that's being inspected in the iteration by doing print score. So here, we're going to have the loop executing. It's going to go to 66, check the if statement, it evaluates the false, so we don't execute the break. Goes to 72, checks the if statement, evaluates the false, it's not 54, so we don't execute the break. Then we get to 54, the print statement executes. Then we go to the if statement, it evaluates the true, so we execute break, and we exit the loop. And we never iterate through 67 or 81 because of the break statement. So you can see these are often paired with if statements to basically control whether you want to skip to the next iteration or if you want to completely exit out of the loop. Okay, so that's all for the week 3 lecture. We're going to have the week 3 workshop now for 70 minutes. It's going to be OC01 and OC03.
Instructions for this week. If you've been to previous weeks, it should be fairly okay. Open the week 3 notebook. It's at the go.uwcs.uk/Python link. Please attempt the week 2 Wahoot stuff, the new version, before attempting the week 3 stuff. You do have to re-download the week 2 Wahoot. And again, everything you need is at that link. So hopefully, that should